Bismillahirrahmanirrahim. Assalamu alaikum. Dear viewers, I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So our today's lecture is about molecular orbital representation for heteronuclear diatomic molecules, for example, carbon monoxide. As in the previous video, we have studied the molecular orbital representation for hydrogen fluoride molecule, as its energy level sequence for molecular orbitals was sigma 2, that means bonding molecular orbital, that is sigma filled with 2 electrons, and sigma star was empty. So according to this one, its bond order is, here it is the 2 electrons divided by 2, that is only 1. So the bond order for hydrogen fluoride is 1. That means that the hydrogen fluoride has been formed with only one bond, that is HF. So now we move towards the next example, that is carbon monoxide. As you know that the atomic number of carbon is 6, that is 1s2, 2s2, 2px remains empty, 2py1 and 2pz1. Similarly, the atomic number of oxygen is 8, that is 1s2, 2s2, 2px1, 2py1 and 2pz with 2 electrons. Now we draw here the atomic orbitals of carbon have been drawn here and the atomic orbitals of oxygen have been drawn here. So atomic orbitals of carbon, that is 1s, 2s and 2px. We will not consider this 1s because it is at the lowest energy level, that is not comparable with those of the oxygen atom. So we will ignore this 1s orbital and we will start from this 2s orbital. Here it is 2s and it is filled with 2 electrons. Then 2px is empty, then 2py1 and 2pz1. Here 2py and z have been partially filled. Now the oxygen, we will also not consider this 1s orbital. We will start from this 2s orbital. It is filled with 2 electrons over here. Remember that the atomic orbitals of oxygen lie at the lowest energy level as compared to that of the carbon. The 2s orbital of the carbon is at bit higher energy as compared to 2s of the oxygen atom. This lies at the least energy level. Here this is the energy level and it increases from bottom to top. Now here comes the 2px1, 2py1, then 2pz filled with 2 electrons. Now this 2s interacts with this 2s and also with these p orbitals, and also these p orbitals interact with these p orbitals of the oxygen atom and also with the 2s. So its interaction with this one, here it interacts with this 2s orbital to form this bonding molecular orbital, that is sigma, and it is completely filled. And in the case of this sigma star, it is empty because here it also forms one non-bonding. This is non-bonding molecular orbital and it is also filled with 2 electrons. That is sigma non-bonding. When 2s interacts with this 2s orbital, then it forms 1 sigma and 1 sigma star. And when this 2s interacts with these p orbitals, and as well these p orbitals also interact with these p orbitals. And when this 2s orbital interacts with these p orbitals, then here this forms the non-bonding orbital, that is also sigma non-bonding. And these p orbitals interact with these p orbitals because all these orbitals interact with both of these. So in this way you may say that 2s with 2s to form sigma and sigma star, then 2px interacts with these 2px to form 2 pi bonds. These two are pi bonds, and here the total number of electrons are 4 and 6. So 2 electrons would be here, 2 would be in these, and 2 other would be in sigma non-bonding. Because you see that, okay, we will discuss this later on. First just see that how many bonds have been formed. When these interact with this one, then 2 pi bonds would be formed and 1 non-bonding orbital would be formed at the equal energy level as those of p orbitals. Then here this pi bond would be accompanied with antibonding molecular orbitals. Here it would be for antibonding and it would also be for pi star. As here there are the 6 electrons, 2, 4 and 2, 6, and these 6 electrons have been here 2, 4 and 6. So these pi star and sigma star would be left vacant. And here this sigma star has been formed also as a result of not only this 2s and 2s, rather there is also some interaction for these 2px. And also here from these 2px. So in this way these bonds have been formed, and this non-bonding is forms as a result of interaction with this 2s with this 2s, because there is energy difference between these two atomic orbitals. So as a result of that, here there is 1 sigma non-bonding orbitals has been formed. And with the help of this we can calculate its bond order, that is 1 orbital is here and 2 orbitals are here, total 6 number of electrons, and there is no electron in the antibonding molecular orbital. 6 by 2 is equal to 3. So the carbon monoxide has been formed by sharing or by forming a triple bond. So thank you very much for watching the video. Please subscribe my channel and press bell icon. Allah Hafiz.